Howdy, AB. It's Miss Kosh. First of all, I discovered a mistake on the answer key, and then I was asked for help on a couple problems. So I want to do all of those things, hopefully, in one video, and we'll see what happens. So the first thing I'm going to look at is number 4 from the review. And we came up with this domain right here because we can't take the square root of a negative. So when I see this square root of x on the denominator, I can't take that. I need to make sure that x has to be greater than or equal to 0. And then so that's the first thing we can't do. We can't take the square root of a negative, and since you're not Chuck Norris, you can't divide by 0. So I cannot let this had better not equal 0, the denominator right there. So I have that 4 cannot equal the square root of x. If I square both sides, 16 cannot equal x. And so that's how we got the domain right here. That was not my mistake. The mistake comes in a second. So what we did next is I solved the inequality. I want 1, or f of x, I like it written this way better. F of x is greater than or equal to 1. So I came along and said, okay, what was f of x? This 4 minus x squared over 4 minus the square root of x is greater than or equal to 1. I ignored the inequalities for a second and went and made a sign diagram. However, I made a mistake. So what happens here, what I need to consider is I have, I can equal 0. I cannot equal, is that true? Okay, hang on, my bad. So let me finish this up. If I have 4 minus x squared is greater, you know what, I said I was going to just ignore the inequality. This equals 4 minus the square root of x. The 4s, I subtract 4 from both sides, they're gone. Divide by -1, it's gone. This would tell me that x squared is equal to the square root of x. And what I know about this is that this is x squared. It's this lovely parabola like that. This is the square root of x. And they have the point 0, 0 in common, and they have the point, well, where x is equal to 1. And all I care about is that x is equal to 0 right there. So at 0 and at 1, this gives me a true statement. Okay? So I can draw a little solid line for 1 because it can be equal to 1. Well, now what we forgot is that 16 is not in my domain. So not drawn to scale, but 16 is not in my domain, so I'm going to have to put, well, you know what? Hang on just a second. Oh, well, there goes that. Let's make this line a little bit longer. Not drawn to scale, but here we go. So I need to consider the fact, I can't just ignore the fact that 16 is not in my domain. So those are the things that I need to put on my sign chart. And so now when I cruise along here and say, okay, well, what's f of -1? Oh, well, f of -1 is not even defined because it's not in my domain. So that would not give me a true statement. That's a little X to mark that it's false. Okay, so now what? Let's say, what is f of, I want a number in between 0 and 1, but I want something that's a perfect square because I'm going to have to take the square root. So I'm going to say 1/4. So what I have here, f of 1/4 would be equal to 4 minus 1 over 16 divided by 4 minus 1/2. And this gives me 3 and 15/16. So 3 and 15 over 16. We don't usually use mixed numbers, but for this, and this gives me 3.5. I'm really too lazy to, 48 plus 15. So 58 plus 63 over 16 divided by, this is equal, 7 over 2. What a beating. I'm sorry. Okay, so I'm just trying to be precise because, anyway. But here's what I notice. 3 and 15/16 divided by 3 and 1/2. The top is bigger than the bottom, so when you divide that, it's going to be bigger than 1. So let me show you. So when I divide by 7/2, that means I'm multiplying by 2/7. This becomes 8, so I have 63 over 56, which is indeed greater than, well, we don't even need the equal sign. It's greater than 1. Okay, so when I plug in 1/4, I ended up getting something. I ended up making my f of x greater than 1, so this is valid. Okay, now let's try something. Let's plug something in this interval right here. I want a perfect square because I'm going to have to take the square root. So let's say f of 4. Okay, so if I say f of 4, I have 4 minus 16 over 4 minus 2 once I square it and then square root it. This gives me negative 12 over 2, which is equal to negative 6. Negative 6 is not greater than or equal to 1, so that is false. But now here's the part that I didn't consider in the past, and I should have. My apologies. I'm good, but I'm not perfect. Okay, and that is f of, say, 25. Let's get something that's out here and a perfect square. So what I have is I have 4 minus 25 squared. That's one that I have memorized. I encourage you to memorize that one also. And then this becomes 4 minus the square root of 25 is 5. And so I get a negative 621 over a negative 1, which is a positive 621, which is indeed bigger than 1. Okay, so what I should say, my final answer, let's use a new color. My final answer should be from 0 to 1, pick it up again from 16, but it can't be equal to 16, to infinity. Okay, and now let's use Desmos to help us check what's happening. So I typed it in already. And here's what I see when I go to Desmos. So I'm like, oh, okay, well this is 0, this is 1. It's greater than, notice I graphed those two sides of the equation, and it's the red is above the blue between 0 and 1. So I think, oh, fantastic, I'm done. But what I forgot is I forgot to consider when I'm beyond 16. Well, so I look at this and I'm thinking, oh, fantastic. I don't see anything over there. There's nothing bigger than 16. I'm done. Everything's great. No, 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 no. Remember from a second ago, we found f of 25 was equal to 621. So my scale over here on Desmos is not good. So I'm going to hit that little wrench. What is that? Yeah. The little tool thing up there. And I'm going to change my y values to go a whole lot bigger. We had 620, so let's say 700, 710. I just typed in the wrong thing. Okay, and so what I see, and even that I needed to adjust, what I see is that there is a part of the graph over there, and I needed to consider that. And notice all of that mess of a graph is above 1. So that is the, this is our correct final answer. And that's how I missed it, because it wasn't in the correct scale. I didn't have my calculator calibrated or my Desmos showing me everything that I needed to see. So my apologies, there's the correct answer. Okay, I had a question on number 13. Okay, let's see. So they want on this one, this is something that's only going to relate to HL. SL, I expect you to be able to work with these kind of functions, but I'm not going to have you deal with the inequalities of them. Okay, so what I did is I wrote out, okay, f of x has to be, I'm right here, f of x has to be less than or equal to g of x, so I wrote that out. And then we need to consider the asymptotes, okay, because the graph is undefined at -1 and at +4. And so then I also want to see, okay, when are they equal? So what I did is I cross multiplied, so I have x plus 4 times x minus 4, that's an a plus b times a minus b gives me a squared minus b squared. And then I said, okay, what's x plus 1 times x minus 2? That FOILed out to this. And so then I came along, I didn't show maybe all of my thoughts, or maybe I did. The x squareds cancel. I have a -16 is equal to -x minus 2. Add 2, I'm at -14 is equal to -x. Divide by -1, and there's my answer. Okay, so that is something I need to consider. And then once again, we're going to do a sign diagram to see which ones give me a true and a false statement. So I use the checks to represent where it's true and the x's to represent where it's false. And I plugged in some different values, and I'm not going to keep talking about that one because the video is getting too long. So if you have questions, let me know. There was also a question on number 17. Okay, so sketch the graph. With that one, I don't necessarily notice. The very first thing I did is I rewrote the problem so that the x's are the first part. So from what I remember, from what I have memorized from my rules, and this is, I think, good for HL and SL so far. The inequality, maybe not for SL, but the first part, I think, let's keep going. Okay, so from my rules, I know that I have an asymptote at x equals 2 because I'm not Chuck Norris. I can't divide by 0. And it's the same degree. And when I say same degree, I mean the degree of this x and the degree of that x are both 1. So I divide my leading coefficients, and I have an asymptote of y equals -3. So when I go to graph that, what I can do, that's what I had memorized before. So what I can do is I can draw in an asymptote and draw in 1, 2, 3, an asymptote, pretend I can draw a straight line. And then I'm not sure, okay, am I going to be in quadrants 1 and 3, or, which it's not exactly, but you know what I mean, or am I going to be in quadrants here, like in 2 and 4? So what I'm going to do is I can either pick a point, plug in a value. I don't know what's wrong with me. So say I plugged in 0, then I'd have a negative 1/2. So what I see when x equals 0, then this right here, all of this is gone, and I'm just left with 1 over negative 2, which is negative 1/2. And so that tells me that I'm going to do something like this, and therefore I also have to do something like this. Now, it also is helpful to look and see what the transformations are, and that's what I did with this right here. Okay, I wrote down my leading coefficients, which was just negative 3 and 1, and I'm dividing by a positive 2, bring down the negative 3 times 2 is negative 6. This gives me a negative 5. So this graph, y is equal to negative 3 plus, well, negative 5 over x minus 2. That's not the form where we can see the transformations, but it's really close. So this is negative 5 over x minus 2 minus 3. This negative right here tells me that there's been a reflection. And to be honest with you, it doesn't really matter if you're here and here, and then you reflect over the x-axis, then reflecting over the x-axis, this goes here and this goes there. And so then we'd be like this. Okay, I'm going to really have fun with colors. If we reflected over the y, that means I reflect over this way, and I'd have this, and then this guy would get reflected to there, and it's the same. Okay, this is a unique, it may not be the only one, but most parent functions don't do something like that, where the reflection over the x and the reflection over the y give you the same thing, but this one does. So it's kind of fun and cool and exciting. Okay, so continuing on, it had a reflection over, I would say, the x-axis, and then it had a vertical stretch of 5. It shifted, so it shifted to the right 2 and down 3, right 2, down 3, and notice that point right here had been at 0, 0, and then it went right 2, down 3, and there we go. Everything I've just said right there is fair game for both HL and SL. They wanted the points of intersections. Okay. Find that where y equals 0, set the numerator equal to 0. So that's how we get that 1/3. Then the next thing they asked us to solve the inequality. Well, if you think about looking at this graph, if you remember, this part is HL only. In the past, well, this year it's HL only. Who knows what will happen next year? What happens here is anything that goes, this is one of those cool transformations. Anything that happens below the x-axis is now going to reflect up. So this kind of starts going, oh, hang on, that's a little too steep. We now have an asymptote at positive 3. 1, 2, 3. So here's that new asymptote, and this thing is going to kind of, from this point, it starts, notability, leave me alone. It starts doing that sort of thing. It's this piece right here has been reflected to be that piece. Okay, that was too much. Undo. Anyway, there we go. This right here has to reflect up. You don't know what I'm saying when I say this. Okay, this piece here reflects up to be that. And that's how we get that graph. And so we want to know, okay, well, where does this intersect with 2? Well, what's going to happen is we're going to have one value right here where it intersects. And what did I find? I found that value, when I set it equal to 2, was equal to, oh, I lied to you. It's going to be here and here. So it has 2 places. I didn't mean to lie to you, but I did. It's got a value here, and it's going to have a negative value, and it's going to have a positive value, is what I'm seeing. Yep. Okay, so I said, well, one of them, 1 minus x, 3x over x minus 2. I'm looking at this part. And we multiply that through. That gives us 5x is equal to 5, so x is equal to 1. And that makes sense in my graph. Doesn't that appear to be looking at like 1? And then we set it equal to the negative 2. And so I made a sign diagram, or really what I need to do is I need to see, okay, where is it above that graph? No, I lied. We want the new inequality right there to be less than 2. So I want to know where is it below, and it's going to go right in, it's going to go in this little thing. So it's from one intersection to the other, and that's where it's going to be less than. So it's from -3 to +1. All right, hope that was helpful. Let me know if you have additional questions.